Hey guys, welcome back to another live stream. And in today's stream, um we're gonna be doing some problems on one prep. So I'm not sponsored or anything. This is just like the first thing I saw for this. I'm pretty sure there's other websites as well that do the same thing. But this one seems fine. So let's start off with the inactive hard math questions here. And start off right here. So I actually learned this nice Desmos thing today, just now. So if we just move this over to here somewhere. Okay. I don't especially like that. And I can't resize it either. Okay, I guess I'm gonna put it like that. So if I take an ordered list, so like that, with the two equations they gave us, then I put a tilde in another ordered list. That, where I do wrong. Oh, here. There we go. So it tells us the value of y that satisfies this equation is 1.5. Just check that and that's correct. So you can obviously do this a lot quicker. How long did that take me? I guess it doesn't tell me. But yeah, you can just real quick do that, which is nice. Let's try doing it faster this time. Oh yeah, so that's a timer for each question. So no solution. So it says p equals 3. Okay, so I guess we did something wrong here. So the system has no solution. So what's the value of p for the system to not have a solution? Um, so how do we do this one? So basically we need to tell Desmos that there's no solution to this. 6. If the lines are parallel and distinct, are parallel if the coefficients are the same. Okay, let me try something. So what if how do I use regression on Desmos to solve this problem? So that's the explanation of the problem. And then this is what I put in so far, but answer dot for P was incorrect. What will I add to this ordered list expression to tell it that there's supposed to be no solution? And then I guess I'll also copy paste the question itself for good measure if it'll let me do that. So let's see if so I got the system. I don't want to do all this though. But oh yeah, I just use a slider, I guess. Okay. Can we force regression to work? Let's find out. What is this thing happening? He's trying to tell me there's no easy way out. Okay. Okay. So instead, what we got to do is we have to put this thing. There probably is a way to use regression. Someday I'll figure it out. Yes. So we put in a slider, and then we just slide that over to 6, and it'll become parallel. It's basically what we're doing, but let me just tell Grok about this and see if it has anything to say. I have done it in Ismos like this, but a slider can be susceptible to human error, and solving on paper will take too long. How I don't want to derive any of this. Well, slider it is, I guess. Basically the most practical way to do it. I don't want to donate. Let me move the calculator. Okay. No solution again. It's the value of t. So let's see if we can reliably do this slider thing. And let's see how long this takes as well. So essentially, so if we do 8 here, that should be right. Yeah. How long did that take? 49 seconds. Okay. 2 are good to know. Come on. Let me see this better. During a month, Morgan ran R miles at 5 miles an hour and biked B miles at 10 miles an hour. She ran and biked a total of 200 miles that month, and she biked for twice as many hours as she ran. So, bike is B miles. Why is it even talking about the hours? So R plus B is 200 miles. Um, Yo, what even is this? Okay, so she ran R miles at 5 miles per hour. So 5 miles an hour. So 5 miles times T hours plus 10 miles times T hours is also equal to 200. We're getting a number for T here. Wait. She biked for twice as many hours as she ran. So how many hours does she run at? Three minutes on this question so far. This is why we need more practice, guys. But total number of miles. So we're looking for the total number of miles that she biked during the month. So we need B. We need to figure out B here. Right now it's saying B is equal to 0. They don't give us the amount of hours. Well, we have to say hours ran and hours biked, basically. So we have to do T ran. How do I put in a subscript? Fine. No, that's not working either. Fine. T1, T2. So 5T1 plus 10T2. So 2 is the number of miles biked. And T is the amount of hours biked and ran. So that means T2 is equal to 2T1. It still says B is 0 miles. So that's not right. So we need to get B to be more miles. R plus B is 200. So 16 hours. 16 times 10 is 160. So 160 maybe, because it's saying T2 is equal to 16, but yet she biked. I guess I can also put in R is equal to R and B. So R is equal to 5T1, B is equal to 10T2. There we go. Yeah, 160. Yeah, now it's all working out. So we had to include that R is equal to what R is equal to. Now if we check it, yeah, it's 160. See how they did it. They did all this stuff. Yeah. But yeah, regression worked in the end, but first time, so a little rusty. But I think a little more practice probably easier. But it's basically the formula on how you do it is you can just regress it all. It's pretty tough. So you just gotta get a little faster on this. This literally took me 7 minutes, which is not good time on SAT. But hopefully we see some more problems like this in the one prep question bank thing. Let me check something. Just give me a second here. Yes, give me a second. I have to go do something real quick. Yeah, guys, so I'm just uploading some Reddit videos right now for you guys. Actually, guys, I'm gonna worry about that later. So they're not working right now. Let's get back to this right here. So, okay, let's try the next regression problem. If the system equation has an infinite number of solutions, what's the value of A? So this is gonna be another slider one. 1/2 x plus 1/3 y equals 1/6. Ax plus y equals c. I'm just gonna put in a slider for. Oh, there's a c there. Let's put the c back to 0. So now we just gotta see when this overlaps right here. 1.5, is that an option right here? 1.5 is 3/2. Check that. Yep, that's right. And if we just move the c over here, then it'll overlap like that. If xy is the answer to the system of equations above, what's the value of 3x plus 3y? So we're going to want to go right here, and we're going to want to just so we're going to want to type in 7x minus 5y, and then regression, it's going to be 4, and then of course we're going to put y1. All right, what's the problem now? Okay. 4x1 minus 8y1 equals 9. So then we need 3x1 plus 3y1, and that's equal to -5. So we're just going to check that real quick. And that was the correct answer right there. So as you can see, guys, Desmos makes it very, very nice and easy for us, like that. Move on to the next problem right here. A movie theater sells 2 types of tickets, adults for 12 and children for 8. The theater sold 30 tickets for a total of $300. How many in dollars was spent on adult tickets? This is another regression problem here. Let's start off like that. So they sell, so let's make an equation. So 12A for adult tickets plus 8C is equal to 30. wait, no, 300. And then A plus C is equal to 30. So then adult tickets is 15. 15. But then we need how much money was spent on adult tickets. So it's actually going to be 15A, which is equal to 225. Like that. If we check that real quick, and it says it's wrong. So let's see what we did wrong here. So 2 types of tickets, adult for 12, children for 8, 300. They sold 30 tickets for a total of 300. How much in dollars was spent on adult tickets? Oh, it's 12A. Yeah. Yeah, guys, this is a silly mistake. You should not be making it. 12A, you're gonna want 12A right there for these $12 per ticket. Obviously. So now another regression problem. So you can see regression is very versatile. 5x plus 14y is equal to 45. Another one's equal to 27. 10x plus 7y is equal to 27. Oh, 1, 1, 1, 1. Come on, what's up? Oh, yeah. You guys remember tilde? It's always tilde. So now we need the value of x1, y1, 1.8, 1.8. Check that, and it's correct. So guys, if you just want me to show what's on the calculator right here, that's what I got on the calculator right there. So yeah, so you just put in both of the equations, you put a tilde, and then you put the answers to the equations, and then it relates them and it figures out all that. Very, very useful. Now let's go over to the next one. No solution again, which means we need to do a slider. So you don't actually have to type the y equals, it's kind of a waste of time. Cx plus 10. Put in that slider here. And now you're just going to want to go to slide this until they're parallel here. 0.5. And you could also do this way, way faster. Just look, it says 1/2 here. C is right before the X, it's also 1/2, so you could just do that in a couple seconds straight up. You don't need to put it into Desmo, so probably the better way is to just do that. The slope has to be the same for it to be parallel, which means no solution. So here we can just do 2 like that. So you can see literally 9 seconds. That's all it took. Here we go. So Store A sells raspberries for $5.50 per pint. Okay. So $5.50 per pint and blackberries for $5.50 plus 3. Store A no wait, it's the same purchase of blackberries and blueberries, which means so instead of A, let's use R here. So now the number of blackberries is 5 right here. Just check that, and that's correct. So yeah, if you want me to show off the calculator right here is what it looks like. And then last but not least, we got this. AX plus BY equals C. So we just divide the whole thing by 2. This will be the same. This will be the same. I mean, like same slope, but this should be parallel here. So we just check that. Yeah, there we go. That's correct. That was the last one in this set right here. So yeah, how do we go back to question bank here? Um, so we just finished the system of 2 linear equations in 2 variables. You can see there's a bunch of stuff here. And so yeah, guys, now I'm gonna go on my laptop and I'm gonna upload all my videos. So thanks for tuning into the stream.